I'm bringing to the stage Paul Mugridge, Business System Analyst.
Change the controller here. Okay. Good morning, everyone. My name is Paul Mugridge. I'm a Business Systems Analyst with the City of Kelowna. I've been at the city for about 15 years. Sorry? Oh. And I've got a background in software development and have recently just joined the GIS and data analytics team. Today I'm going to be presenting a tool that I built for the city that allows users to quickly and easily access and share SCADA data. Before I begin, I'd like to get started with a description of our beautiful city. Kelowna is located on the traditional, ancestral, and unceded territory of the Silex Okanagan people. It's located on the eastern shores of Okanagan Lake, surrounded by mountains, lakes, vineyards. It's a beautiful place to live. It's home to about 150,000 people, and we have about 1,000 dedicated staff at the city. On today's agenda, I'm going to first discuss what SCADA, oh, that didn't come up right, what SCADA data is. I'm going to also talk about the infrastructure that we've set up at the City of Kelowna for SCADA systems. I'm going to discuss the challenges of SCADA data and how it led us to build the SCADA data exporter. I'm going to give a brief demo of the SCADA exporter, and then I'll talk about the next steps for the city. So I think this is the wrong presentation, but I can work with it. What is SCADA? SCADA is it basically stands for Supervisory Control and Data Acquisition. Essentially, it's a collection of hardware and software elements that are used to control and monitor plant floor machinery. At the city, we've got thousands of valves, sensors, pumps collecting data as often as every few seconds. That data can be viewed in the SCADA system, like the real-time data, so they can make important decisions in an instant. But it can also be exported to other tools like Power BI dashboards so that they can visualize trends. At the city, we've got two SCADA systems. We've got a GE platform for our water systems, and we've also got, we use the Siemens platform for our wastewater. Both of those systems are on their own private network, and which makes it a challenge because we need to actually use that data to make informed decisions. So it's skipping, I'll just go back. And so what we've done is we ended up creating a reporting historian on our own internal system, and we've got a one-way communication from those SCADA systems to the reporting system so that we can actually consume that data. The amount of data that we collect at the city on all these sensors is overwhelming, and I'm sure it's similar for most municipalities, but it's critical information to make informed decisions. So some of the challenges that we face with SCADA and SCADA data is really the biggest challenges seems to be around security. SCADA systems are vital for infrastructure in the city, like for wastewater treatment plants and water facilities. And this makes it really difficult to integrate with other systems. We need the SCADA system to be scalable and reliable. It needs to keep operating without interruption. Those first four challenges I described are more really about the infrastructure and the setup of the system. So I'm going to focus more on the data management challenges that we face. So, so this is a screenshot of a plugin that comes with one of our SCADA systems. So most SCADA systems have a bunch of different client tools that you can install. This plugin just shows an error that I got when I was trying to export data from multiple tags. and that's kind of problematic for a lot of the people that are actually going to consume the data or our third-party consultants, because they're often looking for data from dozens of tags at a given time. And a tag, to define that, is essentially just a collection of data associated with a valve or a pump or a sensor. So these tools can also be really slow. So let's just jump forward again. This is another tool. It's called the Historian Interactive SQL, and it's a challenge for users because they need to be quite technical, or they need a lot of training on how to use these tools. You can also see in the bottom left corner, I've circled 5,000. That's because this query only returns 5,000 records at a time. And I know it can be configured differently, but it's difficult for non-technical users to do that. The other challenges with it is it can be quite slow to pull that data. This query itself isn't a huge query, but it does take a bit of time. And then the fact that it only returns 5,000 records would require a lot of copy-paste operations for our users. And they're limiting in terms of the number of records and the number of tags that they can get. And you can purchase third-party tools, but they're very expensive, and they do require a lot of training and technical expertise to use. So, oops. So the SCADA exporter is basically composed of 3 different components. The first is we use is the Esri Survey 123 for our front end. In the screenshot on the right, you can kind of see that form, and it allows you to select 1 or more tags, and you can choose a start and end date on that. And then you can also choose different calculation types. So you can choose to have calculated data, interpolated data, sample data, or just even the raw data. The bottom left screen is an FME workflow, and I'm going to go back there. And it is basically triggered by a webhook from the Survey 123 form. And all it's really doing is it's basically extracting the parameters from that form and basically calling an executable that I wrote. The other little screenshot there is just a picture of a bit of the code that's written. And it's written in C#, and it essentially is calling the APIs to get the calculator interpolated data, and it's writing that with OpenXML to an Excel spreadsheet. The next steps that we're looking at after I show this, we're looking at what are we going to do with that data. We are basically currently building different Power BI visualizations to look at a bunch of pumps around the city. We're using the SCADA data to alert users or certain staff of certain conditions if thresholds are crossed, like for example high turbidity or too much pressure in a valve or something. We have a lot of other things that we can do with that SCADA. I know that I could improve the look and feel of that front end, and probably eliminate even the FME workflow, or even change the OpenXML and the C# to use something like FME just directly through it. Although I did find it a lot easier as having a software background to just just write it in code, because it was just a quick and dirty tool that we basically wrote for staff to use. So here's the SCADA, the Survey 123. You can see that list has got thousands of tags and stuff in it, and when you type, it sort of filters it down so you can easily find the tags that you want. The naming convention is not my favorite, but the people that know the data know the tags that they're looking for. So in this demo, I'm going to just choose 3 different tags. And that should be done. You can see that they're all sort of highlighted down below to show which ones are selected. I am going to run a report for all of 2023. So sorry for the delay here. I like the speed of this. I wish I could have sped this part up, but so once I've chosen my date range of the data I want, I can choose the calculation type or the aggregation type. So you can choose sample data, interpolated data, calculated data, or just even print out the raw data. And when you choose, for example, the calculated data or the sample data, you get all these sub-options. So you can look for the last value or the max value or look at the standard deviation. And these are all API calls that come with the SCADA system, or at least with the GE. But in this sample, I'm just going to choose the interpolated and do a 5-minute interval. At the bottom, I'm entering my email address so that I get notified when the report's actually completed. So I've submitted that, and I'm going to just do another quick one here, and just to show you the difference between something like the raw data versus a calculated report. So I'm just going to do a single tag here, and I'm going to just choose a small window of about 2 weeks, just to show the actual amount of data that these systems generate. And you can imagine that there's 4,000 tags, and this is just one of them. So I'll choose the date range to the 15th, and I'll choose raw data. And again, I'll put my email address in and submit the form here. So now what I'm going to do is just show you my inbox, just to show you the emails that are coming to let me know that the report's done. So you can see that one is completed already. In that email, you can see all the parameters involved with that query. The other one just came in just as we're talking. So you have all these different parameters, and you've got a link to the server, the Excel spreadsheet that you can just click on and go to. So at the top, you can see the different tag names, the description of those tags, and the units. So the first two are flow rates, and the last one I think was pressure. But that just generated 105,000 records every 5 minutes for 2023. So I'll close that one, and I'll look at the raw data one, and again, it's another link. It's got the parameters there. I open up the file, and this, because it's raw data, if I had chosen more than one tag, you would see 2 rows, one with the date and the value, because they can be collected at different sampling rates. And this, just in a 2-week period, has 64,000 records. Each of these spreadsheets also has a parameters tab that also shows you the parameters associated with that report. So consultants and the consumers of the data can actually see that. And just one final little bit here with this demo. I'm just going to show where those files are going. And they're basically on our water reporting server. And because of the naming conventions, and it's really difficult, these long tag names, I've created, the code basically creates a folder for each unique user so that they can have their own export files and easily find them without having to try to filter through all the other people's reports as well. So that's the end of my demo. I've already talked a bit about our next steps, improving the tool a bit, but also working on Power BI visualizations, and yeah, so that we can make better decisions at the city.